Yo, how's it going, guys? Welcome back to another video. Today we'll be discussing about question set number 33. So this is the continuation of question set number 31 and 32. So in case you guys haven't watched the 31st and 31 and 31st and 32nd video, so I urge you to watch that. So here's the ER diagram for the early issue center DB. So early issue center DB is the DB which we have created in 31st and 32nd video. So to be specific, we have created 30 in early issue center in 31st DB 31st question set, and then included the tables like 6 different tables, and in 32nd we have also included like 7 different tables. So that's like a summary of what we did in question set number 31 and 32. So let me give you guys some time to read the question. Just pause the video right here and read the question. I think you guys have read the question, so let me explain to you what this means. So now we have, as for the first question, we have to find the relationship between user and user type. So suppose like, so these are the users I can think from the top of my head. So they are like normal users, normal customers. So normal customers, and you could have like suppliers, right, which suppliers show to this good. So and they are like admins to manage the database. So this all falls into the user category. And suppose there are like 10 people normal customers from exist within the user table. So it's the table I'm talking about. So when each time a normal customer register, you don't have to see you don't the user type is repeating within the user table. So to avoid that, you can create a one-to-many relationship between these two tables. So user is the repeating side and user type is the non-repeating side. So that's the logic goes into the first completing the first question. The second question suggests that you have to find the relationship between user and the gender. So this follows like the same logic. So suppose they are like users, suppose they are like 10 males and 20 females. So I'm taking like a hypothetical number. So each time a male user is added to the user table, the gender is repeating. So to avoid that, we create a separate table called gender and give the male gender the gender ID 1, and only gender ID will repeat in the user table. To do that, you have to create a one-to-many relationship between the gender and user table. So first select the repeating side and then the non-repeating side. So let me enlarge this. So I have answered the first and the second questions. So the third question suggests that we have to find the relationship between user and system login. So this is like a different story, right? Only one user can have one user can have only one system login which contain that user's username and password. So that's like a so this is like a one-to-one relationship. When we consider from the system login side, one username, the username and password, the combination of username and password belongs only to one user, only to that user only. So This is like from both sides. This looks like a one-to-one relationship. So, and if we put the what do you call user ID into the system login table, we could easily retrieve data between these tables. So you could search like the user ID and get like the, if you know the user ID, you get the username and password and verify that user's login. So to do that, first select the site you wanna make the foreign key, and then select the site the primary key is located. So that's that. That answers the third question. The fourth question suggests that you have to find the relationship between user and address. So to do that, so suppose there are like 5 users who are having the same address. So what I'm talking about is like there could be like in the same family, mother, father, sister, brother, uh, suppose grandmother, grandfather. Okay, so there are like up to like many family members uh, in a family, and they all could be having like different user accounts. So the user in so multiple users can own up to one address, and but one user can have only one address. So there's the logic goes into this. So this is like a one-to-many relationship. So user is the repeating side, and then the address is the non-repeating side. So first select the repeating side and then the non-repeating side. Now we have to okay, so I have answered the fourth question successfully. The fifth question suggests that we have to find the relationship between address and city. So suppose there are like 10 addresses from the same city, Anuradhapura. So Anuradhapura city, Anuradhapura is repeating here. So what we do is we create a separate table called city and give Anuradhapura a city ID, and only the city ID is repeating in address table. So there's like the so less storage is used, because Anuradhapura has like suppose Anuradhapura has like 10 characters, and only one character is now repeating because we have given like this Anuradhapura. So Anuradhapura is represented by 1, also only 10 only one character is repeating here. So that's that. So address is the repeating side and city is the non-repeating side. So this is like a one-to-many relationship between these two tables. And that answers the fifth question. So the sixth question suggests that we have to find the relationship between product and brand table. So product and, so these are the two tables, product and brand table. So let me get my notepad to explain to you how to create the relationship between these two. So product. So suppose they are like shoe 1, shoe 2, shoe 1, shoe 2, shoe 3. So suppose, and the brands are like DSI, Nike, Adidas, or whatever the brands. So suppose shoe 1 is owned by DSI, and shoe 2 is owned by DSI, and shoe 3 is owned by Nike. So DSI owns like 2 shoes, and so the brand, so here if we were to insert the details of product table, so product table, and this will be the answer. So shoe 1 by DSI, shoe 2 by DSI. So as you can see, the DSI is repeating here, and so we created a separate table to store the brand name DSI, and we have given the given that brand name a brand ID and only brand. So and the so if we create a like a one-to-many relationship between these two tables, only the brand ID is repeating, so they are like less repeating, and you can save like many spaces, many space. So this is like the repeating side and this is the non-repeating side. So that answers the sixth question. Some question suggests that you have to find the relationship between user and GRN. So GRN could be so the only users that are having GRNs are like suppliers. So suppose they are like supplier 1, supplier 2, and then supplier 3, right? So supplier 1 can have like the first GRN, and supplier 2 could have like supplier 1 also could have like same GRN, and yeah, so this belongs to supplier 1, and GRN3 is this belongs to supplier 2. So if we were to uh, insert columns into this, so if we were to insert details into these tables, so suppose GRN1 supply 1, right? So GRN2 supply 1. So the supply is repeating and GRN is not repeating. So this is the repeating side and this is the non-repeating side, right? Okay. Okay. So here's the repeating side and here's the non-repeating side, right? No, right? Because one user means like supply. So okay, so I did wrong here. The logic is right, but one supply can have up to many GRNs, as he would say, like, so one supply can have too many GRNs. So that's the logic that I wanna get in. So yeah. So this is right. This might be a little bit confusing, but okay, so there's like a one-to-one relationship if we consider this. So supply 1 can have GRN1 and GRN2, supply 2 can have GRN3, so there's like one-to-one relation. But we consider from the GRN side, this is like a one-to-one relationship between the GRN and the supply, or you could call as GRN and user. So this relationship is correct. Okay. So the eighth question suggests that we have to create a relationship between GRN and GRN item. So suppose we have to create a relationship between these two. So there could be like so GRN item must only include one GRN, but one GRN can have up to multiple items. So let me first, so this is like one-to-one relationship, and first select the repeating side and then the non-repeating side, and yeah, GRN means good receive note. So this is the good receive note. So this is supplied to by the this is supplied to the supplier by the store. So suppose GRN item is having like shoe 1. So and grn item another item is shoe 2, right? So and these are all included. So okay, so these are all included in the first good receive node grn1. So this goes to the, so grn2 could have like shoe 3 and shoe 4. So this is how you create justify the relationship created between them. And yeah, that wraps up the 8th question. So the 9th question suggests that you have to create a relationship between grn item and product table. So this, so to do that the product table, okay, let me think for a second here. So product table can have like one gr no, product table can have like many grn items, and one grn item could be only included in one product. So my logic that goes here is that one supplier can deliver the same product within, one supplier can deliver the same product within multiple days. So that goes for the like only one supplier. So when we consider like multiple suppliers can deliver the same product within multiple days. So that's that. So what I'm trying to say is like so one product can have up to many grn items as he would like, as one suggests, and one grn item could be included in like one product. So suppose grn item is item 1, grn item 1 is shoe 1, so grn item 1 couldn't be like shoe 2 or shoe 3. So this is a no. So this can't be happening. So grn item 1 shall include like one product. So it's like a one-to-one relationship. So first select the repeating side and then the non-repeating side. And that answers the 9th question. The 10th question suggests that we have to create a relationship between grn item and product and stock table. So where are my tables? So grn and product stock. So to do that, let me think for a second. So one stock can have, so this like grn item and stock. Okay. I was wondering that how good like grn and grn stock could be related. So yeah, we have to take the stock and grn item. So that's that. Stock. So one stock can have up to many grn items as one suggests, and one grn item can have or can only be in one stock. So suppose grn item 1 here, right, couldn't be in like multiple stock. So this should be within the stock 1. This item should be within the stock 1. Stock 1 means suppose this is the like the old stock and grn item. So if as for this the grn item, so this is like grn item, so this is like a first grn. For the second grn, suppose we are delivering, as for the GRN item 1, we are delivering the same shoe, so that goes into not this stock but the other stock 2, which is the new stock. So even if the product is the same, but this goes to a different stock because it is supplied on 2 different days and have like 2 different GRNs. So there goes my logic for this. So GRN item can have only one stock, and one stock could have up to multiple GRNs. So first select the repeating side and then the non-repeating side. My throat is so so please excuse me if I make any mistake. That answers the 10th question. So the 11th question suggests that we have to find the relationship between user and invoice. So this is really easy. So this is not as confusing as it is the other questions. So where is, okay, here are my 2 tables. So one user can have like up to many invoices as he would like, because one user can purchase the same product multiple times for a week or multiple times a year, because the shoe size changes or something like that. So or if the same shoe is destroyed or as a gift, so one user can have, what I'm trying to say is one user can have like up to many invoices as that belongs only to him. But from the invoice side, the invoice can only be owned by one user. So invoice couldn't be owned like multiple users. So invoice 1 couldn't be owned by user 1 and user 2 at the same time. So this is a no, and we could only do this. So this is a one-to-many relationship. So the repeating side is invoice and the non-repeating side is user. And yeah, that answers the 11th question. The 12th question suggests that we have to find the relationship between invoice and invoice item. So this is like the same between GRN and GRN item. So one invoice can have up to like many invoice items as per the situation, and one invoice item one invoice item only belongs to one invoice. So it's like a one-to-many relationship. So this is the same as the GRN item and GRN relationship. So that's that. So that answers the 12th question. And the 13th, as for this is like the final question, thank God. So create a relationship between invoice item and stock table. Okay, invoice item and stock. Okay, so here's the logic that goes into this. So suppose so invoice item is generated when so let me copy this. Okay, so let me copy this because GRN and invoice works the same way. So invoice 1, invoice 2, right? Invoice item 1, invoice item 2, right? So second invoice item 1, invoice item 2, right? Okay, so here's the deal. So this goes to if a customer gets like this in like yesterday. Suppose the customer buys this yesterday, this, and only the old stock is and we only get the old stock. So the customer has no other choice but to purchase from the old stock. So that's that. And suppose a new customer comes today. So today we have like a new stock, and he buys the same shoe. So but this time it is invoice item 1. So this time we can't give the customer from the old stock, because we have like a new stock. So to do that, so invoice item must, from the item side, invoice item must include only in one stock, but one stock could have up to many invoice items, as one suggest, as a dealer suggest. So suppose, so what I'm trying to say is stock this. So this is from a different shoe, right? So this goes to the same stock, but what I think I explained that, because so this is like a one-to-one relationship between these two. The repeating side is invoice item, and non-repeating side is stock. So the stock one is repeating here, so that's why. And yeah, oh, I almost forgot to forward engineer this database. So just like the full database. So here's the customer side, and here's the product side. And let me, so I'm not doing this for the first time, and because of that I'm gonna use synchronous model. If you are doing this for the first time, select forward engineer and click next. Don't change any of these, and if all is set, you get a nice database with relationships. So relationships are like logical, so you can see like the foreign keys created from each table. So yeah, I think that wraps up the video. So thank you guys for watching. I hope to see you next time. Peace.